We will refer these books: Fundamentals of Aerospace Navigation and Guidance, and Modern Navigation Guidance and Control, and Tactical Strategic Missile Guidance. So why we are studying this course? The main objective is to describe fundamentals of guidance, navigation, and control, and then we will illustrate the design and analysis of GNC processing. How can you design your guidance navigation system, and how can you analyze the GNC or guidance navigation control system? So before starting, you have clear knowledge of sonar signal processing that we have studied in the previous semester. So again, this course is of 100 marks. 30 is your mid exam, and 40 marks is the final exam, and then you may have multiple assignment which have 20 marks, and then this is the your attendance score. So in the first week, we will study about the deterministic system theory. Uh, I hope you have already studied these topics like introduction to system and control theory application. You may know well about what is a linear dynamic system, also time invariant system, and also you have studied controllability and observability. Then in the second week, numerical techniques. This is again you have already studied many since many years. Laplace transform, differential equation, Z transform, and difference equation. Uh, Again, here we are just repeating these techniques because these techniques will be used in this subject in the guidance and navigation processing system. So the first 2 weeks you have many knowledge. Okay, so just we are discussing more about with regard to the guidance navigation system, how we can apply the deterministic system, because the our guidance navigation system is basically a deterministic system. So and all all guidance system are linear dynamic and linear time invariant systems. So that's why first we will study first we will study these this chapter, and then numerical techniques. And in the week number 3, we will start with guidance, navigation, and control processing, where we will study about the linear, nonlinear intercept of GNC, target signal processing, GNC system design and analysis, and target tracking, state modeling. Then after this, we will apply some filtering and estimation technique, where we use the gamma filter and other technique to obtain the prediction and estimation of the target model using the guidance and navigation system. And week number 5, homing loop. So what is homing loop? How we uh, apply the homing loop in the guidance system, and then the method of adjoints, and what are the how we make a adjoint of deterministic system and closed form solution. Then we will study the navigation in the week number 7, where we will study position fixing system order design relationship. So here week number 7 we will study uh, just introduction part and positioning and what are the design relationship and system order. Then we have a mid exam. Then after the mid exam we will study the navigation in detail, like initial navigation, initially stabilized initial navigation system. This is we call the ISIN system, and step down initial navigation system. Then week number 10, we will study about guidance law, and then we will apply the guidance law for homing guidance and ballistic guidance, and there are many other guidance like static guidance and statical guidance. But first, we will study the homing and ballistic guidance in week number 11 and 12. Also, there is optimal guidance, which is very popular. And week number 13, navigation guidance and filtering design, where we apply the target state estimation algorithm and practical navigation and the guidance filter design. Week number 14, navigation guidance and filtering design, same, but radar tracking, advanced navigation system design. And finally, at the end of the course, before ending the course, we will study some introduction to flight control system design. What is an open loop flight control system? What is closed loop flight control system, guidance system interaction, and right gyro flight control system. So as you can see, uh, this is a very interesting subject, and all chapters are very interesting to study about. So today is a deterministic system theory. Let's start. Okay. Some lecture I will deliver to in the class by means of face-to-face meeting, just I did before. When we have some problems, when we will discuss some problems or examples, then I will take the class physically. But today is just a theoretical, just introduction section and the introduction part and the theory system theory. So we will just study using the here. Okay, so deterministic system theory, first introduction, system problem, and system control theories, application is examples. So what is guidance? Guidance is concerned with the questions: what maneuvers should we perform to cause the vehicle to go where we want while meeting the specification of the mission? It means the vehicle already know the path. So vehicle already know the path, and it should apply specification of the mission. Vehicle already we have assigned some task, we have assigned some mission to the vehicle, so vehicle will follow the reference trajectory using this guidance law. Navigation. Navigation is concerned with the question where is the vehicle. Suppose we want to track the vehicle. So where is a vehicle? What is its velocity? And what are its angular orientation and angular rates? Control is concerned with the question how we control altitude, time of arrival and departure, the trajectory tracking and navigation control. because sometimes we want to avoid the uh, collision of the vehicle, and sometimes we want to avoid when vehicle is driving automatically. Then sometimes what happen, it can be destroyed, it can be crash, it can be crashed with some object when the vehicle sometimes uh,